Students, hi, this is Mr. Bob. This video walks a student through how to collect data from their standard collision predictor app for those research questions, those traffic safety improvements that have to do with increasing the visibility of pedestrians and bikers. If your research question has more to do with reducing the speed of the vehicles, this is not the video you want to watch. You want to watch the other video I made. So let's go ahead and get started to accomplish this. If you look here, this is a standard collision predictor app. You probably created an app very similar to this one earlier in this unit. What we're going to do here is we're going to create a data table, and then we're going to fill out the data table with information that helps us understand what's the relationship between the enhanced visibility that whatever traffic safety improvement we're talking about gives us, and compare that to what's the maximum speed a car can be moving at before a collision occurs. The first thing we're going to do is we're going to create our data table. If you look up here, my cursor is between H and I. I'm just going to shorten this H just to make these two columns a little more easier. So notice I'm creating these columns here, and I'm going to go up here to the borders section. I'm going to create some borders, and I'm going to title this first column. This is going to be starting distance to object, and that's going to be in meters. Okay. Now, if this didn't text wrap normally for you, it might not, it probably looked like this. You want to come up here and you want to wrap the text so it looks like that. This other column, I'm going to call max speed or max vehicle speed before collision occurs. So this is, again, I just want to emphasize, if you didn't get the text wrapping, it may look like this. You want to come up here to this little symbol, and you want to wrap that text. And this one thing I forgot to add, it's always good to add our units, so I'm going to put that in miles per hour. So let's title this table too. We can just call it Table 1, how starting distance to object impacts max vehicle speed to avoid collision. Okay, and to do this, notice this kind of made this thing go down. So what you might want to do here is you might want to merge the cells. And also, again, I believe most of you probably have it looking like this right now. So you'll want to basically wrap the text like that. Okay, so notice, let's go to our collision predictor app. There's a time in here for distraction. For my purposes, I'm going to zero that out because this scenario has nothing to do with distracted driving. We're just looking solely at how does improving the visibility of pedestrians, bikers through either increased painting or striping or decreasing vegetation or whatever it is the improvement you're looking at. So your research question hopefully has some idea, or you can think about it right now. What are the increments that I want to increase the starting distance of the object to represent different enhanced visibility increments? I'm going to use increments of 3 meters. So, excuse me, 4 meters. So if I start the first one at 25 meters, the next one's going to be at 29, then 33, 37. Notice I'm just adding 4 to the number before it, 45, and 49. Okay, now what I'm going to do is I'm going to use my collision predictor app, and I'm going to figure out what is the maximum I can make this speed of vehicle input and still get no collision. Now, right now you can see 30 miles per hour is too high because a collision is occurring because the stopping distance is greater than the distance of the object. So I'm going to dial that down to 23 miles per hour. Notice I'm at no collision. Can I go up to 24 miles per hour and still keep the no collision? Look, yes, I can. Can I go up to 25 miles per hour and keep the no collision? I can. Can I go up to 26? I'm getting closer. Can I make it 27? I can. Can I make it 28? I can. And finally, can I make it 29? No. So 28 miles per hour is the maximum speed a vehicle could be traveling at in this scenario and still have no collisions. So that's what I want to put here in the first, as the first data point in the second column. Now I want to go back up here or down here to the distance of the object. Now I want to increase that to 29 meters. Notice immediately there's no collision again. I want to up this number, the speed of the vehicle, to see what happens. What's the new threshold at which I get a collision? So 29 didn't cause a collision. 30 didn't cause a collision. Do I go to 32? 32 collision occurred. Just 31? 31 a collision occurred. So I think I got to go back to 30. Yep, it looks like 30 miles per hour is the maximum I could be and not have a collision at a starting distance to the object of 29 meters. So I've got my second set of data points. So now what am I going to do next? I'm going to look at 33 meters. I'm going to put 33 down to the distance of the object. And let's go up. Let's go up to 32 miles per hour. That works. Can I go to 34 miles per hour? No, collision occurs. So this one is 33 miles per hour. 33. Okay. Let's go up now to 37 meters, and let's see what happens to the miles per hour. Is 38 miles per hour going to be good? Nope. Is 37? Nope. 36 miles per hour? Nope. 35 miles per hour? Yes. Okay, 35 miles per hour allows me to avoid a collision at 37 meters. 41, I'm just going to go a little more quickly here to just, because I think you get the idea now. 38 collision occurs, so 37 is the max here. Okay, and then I can go up to 45, and that's probably going to get me something around 40 maybe. Nope. 39, no collision. Okay, and finally, my last one, 49. Again, I want to emphasize your numbers will likely be different. 42 gives me a collision, but 41 does not, so it's be 41. Awesome. So now I have this data set. The next part is to take this data set and go to the Desmos link provided by your teacher and input these values into the Desmos application and figure out what pattern best fits. I'm going to start this process, but I'm not going to finish it. Just note here, notice I have this set up already. Again, you want to consult your teacher for a valid Desmos link that would give you all of these patterns already in the C-bar value input. So notice I'm just going to put 25 and 28. That's the first one, 25, 28. What's the second one? 29 and 30. 29, 30. And I'm going to put one more. Again, I'm just going to show you really quickly here what you should do without doing it completely. So notice I've got 3 data points here. What I would want to do is now use the C bar to kind of see which one of these patterns that we've been talking about best fits. I'm going to zoom out a little bit just to help us look a little more carefully here. Again, this is incomplete process the way I'm doing it now because notice I do not have all my data points. You would want at least 6, maybe even 8 data points to get that very good idea of what the pattern is. Okay, so if you look here, none of these patterns are quite fitting, and I want to fiddle with this until I get one pattern that fits best. I'm not going to finish that process, but you know, once you get that pattern, you're going to want to take away the patterns that don't fit very well, and just leave it with the one pattern. Take a screenshot of that and record information as directed by your teacher. Why? Because in your letter to the public official, you're going to use this information, the screenshot, the image of the graph you created, and perhaps some of the data points that you have to help support your claim, whatever your claim is, that you're trying to make to the letter in the letter to the public official. Okay, I think that's it for this video. I hope this is helpful. Again, this is just one example of how you can do this. If I said something that may be contradicted or you're not sure if it's in line with what your teacher said, please talk to your teacher. Thanks so much.